Hello, Tom from Every Step Calculus, EveryStepPhysics.com. A related rates problem regarding a shadow, a man and a lamp post street light. I'm going to read it here. A 6.5 foot tall man walks at 5 feet per second towards a street light that is 15 feet above the ground. At what rate is the end of the man's shadow moving when he is 11 feet from the base of the light? Now, a problem like this, anytime you see, there's two things. There's one is the shadow is changing its length, and the other is the tip of the shadow is moving. Okay? And this one, whenever you see the end of the man's shadow, that would be the tip. In a lot of other problems that you're given the same way. So these little trick things that these professors throw at you, as if calculus isn't tough enough, And then, of course, this is all meaningless stuff. I mean, it never happens in real life. It's all set up for you to find out whether a man is walking 5 feet per second towards a street light. You're going to have to measure it, and you're going to have to time it as he walks to do that. There's no formula that will give you that. So what value is that in real life? You know what I'm saying? You have to get a tape measure out, and you have to watch him walk in a certain length. You have to mark it and time how long it took him to get there for you to find the rate that he's walking. But they make you believe that this stuff is all important and really valuable, and we couldn't have come to the place we are right now without calculus. I say it's baloney. All right. Let's do it. Index 8 to get to my menu. And I'm already at average rate of change. Related rates and average rate of change is the same thing, okay, whatever the problem gives you. I can scroll down now to the R section and choose related rates. It will give me the same program that I've designed. So I'm just going to use this one because I've talked enough and the video is long enough. Okay, and we're going to scroll down here to shadow. There it is. Anytime you see shadow in a problem, you're scrolling to shadow, and with regard to related rates. Here's a lamp post, a person, and a man. Now he's walking. We have to press alpha before you enter anything in these entry lines, and he's walking at alpha 5 feet per second. We're going to find feet here, number 6 feet, and per second is number 1. You can press the number before these things in the menu and come quicker to what you're looking for. And he's walking towards the street light in the problem. Okay, so number 2. So we could press 2 or we could scroll. And of course that just adds a minus sign to it. And we say it's okay. I give you a chance to change it in case you made a mistake. But we're going to enter the lamp height now, which is alpha 15 feet, I think. Alpha 15 feet. And the height of the man is alpha 6.5. The distance that the man is from the post is alpha 11. And I show you everything. You can kind of check it if you want. Go back and change it. We say it's okay. And we're after the tip or the end of the shadow change. Okay, so we're going to scroll up here to number 1 or press the number 1 on the keypad. And we do here's the formula for it. Why, I have no idea, and I don't care either. But this is the formula that you'd write on your paper, and you get an A in this problem. 6.5 y equals 15, and then they do the algebra to multiply 15 times y and x right here. Then they add them together. Here's the y and the y here added together. Gives you 8.5 y, and isolate the x on the left side. Solve for x, etc. Of course, they gave you dx dt, which is really -5 that the man is walking. And we're finding dy dt, which is the y-axis, how the y is changing over time. And it's feet per second, -8.82 feet per second. Now, you'll notice that at no time did the distance the man is from the post enter into these calculations. So that's a trick that they use too. I put it in here so that you can, know that you might want to mark it down in the problem, but as a variable, but it's not related to the problem, okay? So anyways, go to my site, buy my programs, and enjoy them for the rest of your life in your calculator. Load them into your titanium and have them forever. Hey, have a good one. Bye-bye.